Welcome to the All for One Poland webinar. Today's topic is Elastic Stack Monitoring and Optimization for Enterprise Custom Software Infrastructure. I'm happy to introduce our expert, Szymon Szczepański. My name is Octavia Radzio, and I'm the moderator of this meeting. So let's start by sharing some organizational information. Today's webinar is recorded and it will be available on our YouTube channel and on our website. I encourage you to ask any questions. You can do it by using the questions window on the top of the page. And during the session, we're gonna make 2 short breaks during which we will ask you some questions. We want to learn more about your situation in order to address the needs. So now I will present a short introduction about the company, and I will give the floor to Szymon very soon. To begin with, we are All for One Poland, and we support our customers in 4 main areas: implementation and support services for SAP systems, implementation and maintenance of cloud environments, software development, and information security. At Enterprise Software House of All for One Poland, we design and develop custom software for the enterprise world. Enterprise Software House focuses on large, highly scalable custom systems which support the company processes and interactions with customers and other partners. And today's webinar is dedicated to Elastic Stack, a set of tools for monitoring and optimization for enterprise custom software infrastructure. And it's all from my side. Now I will give the floor to our presenter.
Okay, hi everyone. Thank you for introducing me. Let me start with the agenda to show what I'll be talking about today. First, a brief explanation of what Elastic Stack is, the benefits of using it, and short note about other similar tools. Next, we'll dive deeper into Elastic Stack tools, their pros and cons, functionalities offered by them, and we'll end up with real use cases useful in modern enterprise infrastructures. At the end, after a short summary, I'll present a demo with real example of usage. Before we start, I'd like to ask you whether you have ever had any contact with monitoring tools. Octavia, please show the poll, and I'm asking you to choose the answer.
Yes, you should see the poll now. I invite you to participate. All right, thank you very much. I'm closing the poll and we're gonna see the results very soon.
Okay, I can see that most of you know what is Elastic Stack, but the answers was split to 4 answers. So I hope my presentation will be suitable also for people who know Elastic Stack and use it, and also for all of us what you want to know more about Elastic Stack and verify how it works. So I will try to show what Elastic Stack is and how it can be used. We can come back to the presentation. All right. Elastic Stack is a set of tools. It's used to gather different types of data, process them, and store for future operations like visualizations or post-processing. Allows also structurize the data. This solution has a bunch of benefits. With Elastic Stack, you have easy access to your data from one place. Thanks to this, you and your team can be more aware how everything works. It facilitates advanced data processing and analysis. Of course, not everyone should have access to everything, and here comes roles and spaces solution to restrict accesses. Depends on your requirements and team members' responsibilities. Elastic Stack is easy to scale, so it may be used in small systems and very advanced infrastructures as well. It can be expanded as your application grows. Elastic Stack may also save lots of money and increase efficiency of your team, thanks to automatic monitoring your services and instant alerting. So your team can focus on other tasks if nothing wrong happens. They have also easier and more powerful access to logs, what may help them solve the problems faster. Elasticstack is not the only monitoring tool, but it is the one I have the most experience with. Other tools are not full substitutes. They differ in details and have slightly different purposes. So today, let's focus on the most complex one, Elasticstack. In the picture, you can see three parts of Elasticstack. Elasticsearch is a core of entire stack. Kibana is a powerful UI interface. And there are also lots of integration tools to enable data collection. When it comes to advantages, we can mention things such as ease of customization, independence from other tools, scalability, and free plan. However, there are also cons like paid higher plans and possible high resources consumption if Stack is not set up wisely. Who needs it? For small single-app systems, it may be an overkill and redundant cost, but for every other company, it can be really helpful, especially if it has lots of services on different servers or has some critical infrastructure where availability is important. It comes in handy in data analysis departments as well. Let's see what Elasticstack offers. As I said before, Elasticsearch is a core of Elasticstack. It's a non-relational database with Apache Lucene features. Inside indices, we have documents, and structure of every index can be adjusted to our needs. In the picture is an example index mapping with three fields. You can see simple types like integer, text, or keyword, but also objects, lists, dates, booleans, or even binaries are supported. Elasticsearch uses shards, mechanism to divide and duplicate data through different nodes. During creating an index, we define how many shards it should have. Primary shards, red on the diagram, are used to save, store, and read data. Replica shards, blue ones, are used for backup data and enable faster search. In the diagram, we can see three indices. They are split into three nodes. First one has three primary shards and three replicas. It means that it is a service where high efficiency and reliability are very important. Second is focused on quick access to data, so it has one primary shard and two replicas of this shard on other nodes. This ensures faster reading but slower writing. Third index is for temporary data. It's just on one node without any replica. In case of error, there are no backup, but this approach saves spaces. Elasticsearch operates on data. How to obtain that? With Elastic Agents. Those are small applications to install on destination server. After installation, we can manage, update, and configure them without access to this server. They allow to gather different types of information, logs, metrics, web traffic data, and much more. Depends on used integration type and our requirements. Elastic agents are configurable from Fleet pane in Kibana. Fleet server is a tool to connect with all agents on different hosts. This is the place where we can check health of each agent and add new integrations. Last but not least tool from Elasticstack is Kibana. It is a graphical center to present data from Elasticsearch and maintain configuration of the stack. In addition to default tools, it's possible to create own integrations based on REST API. It has multiple endpoints to maintain indices, search data, creating new documents, or even configuring Kibana. If something handles HTTP requests, it may be paired with Elasticstack. And now the most interesting part, examples from real life. One of the most interesting features is collecting and displaying logs from server. Elastic agents have a lot of predefined integrations, which largely work out of the box. It's possible to get logs from Apache servers, Docker containers, Kubernetes pods, databases, raw files in system, etc. Logs can be used in post-processing or display in a live preview. Depends on your requirements and what you want to see at the moment. Second huge advantage of Elastic Stack is collecting metrics from system, Kubernetes, Amazon EC2, ActiveMQ, and others. Those data can be easily used to create charts with CPU, memory, disk, and network consumption. Based on those data, the alerts can be created and will be informed if some parameter exceeds the set threshold. It's especially useful for monitor mounting point spaces, too long high load of CPU, or running out of operation memory. On the picture, you can see the example of some custom dashboard with those information. Metrics are related to the host machine. Nonetheless, it's also possible to track info about application performance. For this purpose, special packages and tools were prepared for different languages. APM can be used in both front-end and back-end side, and it allows monitor specific endpoints, execution time and page loading time. It indicates also impact on final user. For example, if something is slow, but it's visited rarely, it means that impact probably is not big for final user. Of course, it is also possible to integrate custom performance test results from external tools like example JMeter, and then put it to custom dashboard. When we define a geopoint or geoshaped data type for some field in index mapping, it may be used then as a layer in map component to indicate specific points, shapes, or other combinations, like, for example, heat map with boundaries presented on one interactive map. Apart from Elastic Agents, it is also a tool like Heartbeat to monitor application statuses. It checks HTTP, TCP, or TLS states and trigger alert rule if something is not consistent with the defined desired state. It may be simple HTTP response code 200 or complicated body with custom results and additional information useful in alert. When alert is triggered, in default free plan, options like email, Teams, or Slack notifications are disabled. They are available only in the higher plans like Gold or Platinum. Instead of buying more expensive plans, we prepared custom services to inform us via email and Teams about errors. We also prepared connector to Jira to create tickets automatically if some application has error or requests the problem. Thanks to this solution, this solution is fully customizable and can be expanded to other communicators and services in future, like, for example, Slack. Kibana supports custom dashboards with very advanced charts, diagrams, and tables. They can base on multiple inputs and present colorful items, stacked bars, and maps. If some component is universal, it may be used in more than one dashboard with easy and copy and paste approach. So if, for example, some table is useful in one place and it would be useful also for other people in other dashboard, it can be easy copied to other place in Kibana. By default, dashboards are separated pages, but we combined different tools and as a result received custom graphical navigation. Now when someone opens Kibana, there appears default dashboard with our navigation to other dashboards and different Kibana pages. Thanks to this, a user, instead of searching manually some dashboard menu, can use predefined navigation with most frequently used pages. And in the picture is an example prepared by our UX team. Kibana supports also spaces and roles, what I mentioned before. Different users have access to different Kibana pages and Elasticsearch indices. It protects against unauthorized Kibana or REST API access. It is possible to prepare separated roles and accounts for Elasticsearch and Kibana, but combining them is allowed too. Elastic has also integrated tool to prepare end-to-end tests written in Playwright. They can be prepared directly in Kibana or fetched from separated repository. There is also dedicated page to see all tests statuses with specific information like each step execution time, app screenshots, or number of failures. Elasticsearch is a quick search engine with inverted index approach and other mechanism behind. It's a powerful tool to integrate with global searches in shops, marketplaces, or enterprise apps. It supports autocomplete and can be adjusted to different languages like English, Polish, and others. It's also possible to adjust how exact prompt has to be or some typed phrase to allow finding something. Okay, and before we let's go to the ending, I want to ask you about your opinion on Elastic Stack features. Which functionality is the most interesting from you, from your point of view, and maybe if something requires some more information, you can select this option. So Octavia, please show the answers. And there are...
Our top participants are still voting. Right, thank you very much. I'm closing the poll and we're gonna see the results.
Okay, I can see that several options have similar number of votes. I think those points can be developed in near future to make it even more interesting and useful. But I can see that collecting logs and metrics is the most interesting part. Okay, before we go to the demo, I also want to tell something about technical information. Standalone Elastic Stack can be hosted in AWS, Azure, Google Cloud Platform, or any other server. Containerized version is also easier to carry from one provider to another. And also it's option that Elastic offers a cloud approach as well, where Elastic Stack works as a service. But with standalone approach, the server must have appropriate parameters. The most important component is RAM memory. 8 gigabytes is a minimum. The best would be 64 gigabytes. It's worthy to remember that half of available memory should be reserved for Java heap size, but not more than 32 gigabytes. CPU is not so important. General 4 cores units should be enough for standard usage. And it depends on amount of data, disk space requirements may differ. The best would be SSD with 50 gigabytes for start, with option to extend it in the future. Cluster with Elasticsearch node should also have good internet connection. And if you want to know more about your infrastructure, you care about stability, or you want to spend less money, Elastic Stack may be a solution for you. It's not obligatory to use all functionalities, so even if one feature seems to be interesting, it's worthy to at least try this tool yourself. Based on my question before, this may be, for example, collecting the logs and present it in one dashboard with easy access for all team members. Okay, and today I prepared also some demo. Unfortunately, I selected to present spaces in Kibana and alerting when some app is down, but nobody chosen this answer. But I hope it will be also interesting for you. So let me change the screen. Okay. Okay, at first I'm logging as a user 1, and this user has access to space 1. And this space has a default dashboard, and here is information that this dashboard is visible only for user 1, and options in menu are limited. Let me now log out, and I present how to log as a user 2, which have access to space 2. And this space has a other default page, and this default page is also custom dashboard prepared especially for space 2. And as you can see, the options in menu on the left side are lots of them. And here in the dashboards list, we can see just the information about the dashboard prepared for space 2. Okay, and if I open the uptime section, I can see the error because I have access to page on Kibana, but I don't have access to Elasticsearch in this index. Okay, and now I'm logging as a user with all accesses. And here I have access to all spaces, so I select the default one. Default pages also other than pages before. Let's go to the uptime. Okay, at first I can present that every spaces are available for this user too. And now here are monitors for monitoring 2 apps. And here I have running these apps in my VS Code instance. And I prepared a special health check for both applications. First, health check returns just HTTP code 200, but the second one returns also somebody with status. As you can see, the app is alive, but I also prepared some special endpoint to kill this app. So if I execute this, app will stop work. And in my heartbeat configuration, I set checking every 10 seconds is application alive. So when I refresh the monitors, you can see here that application 2 is down because I killed it. Okay, and here we have history about the failures and uptimes. Okay, and when I use the endpoint to make this app alive again, the status returned to app. So we know that application is running properly. Instead of using some endpoints or just some not working service in application, probably sometimes application can be stopped by, for example, Docker daemon. So here I stopped my server with a Node.js application. And now when the down status appears, we can see that error information is other, and we have information that it's no connection to this specific application. So we can do the same for application number 1. Okay, and you can see that application number 1 is also reported as down. Here I'm also presenting that health checks returns errors. And one more thing, I am starting the application again. So application number 2 should return to up state. Okay, and this was a quick presentation how alerting works. And I presented how this information is presented in Kibana. But as I mentioned before, we prepared some special services to connect information from Kibana and Elasticsearch and use information about uptime and downtime about some application endpoints or services. And then depends on our requirements or on environment, we can send a proper notification to Teams, email, or any other service, like, for example, Jira. All right, and now it's time for a Q&A session.
Of course. Here we have some questions from our participants. I encourage you to write down your questions if you want to learn more about today's topic. And let's have a look on the first question. Can I monitor Windows servers with Elastic Stack?
Yes, Windows can be monitored in the same way as Linux servers are, because it uses the Elastic agents as well. Only the installation process may just differ in details, but the flow is the same for Linux and Windows.
And the next question, how to check whether app is running if lots of endpoints must be verified?
I don't know I understand correctly this question, but I think you mean, for example, one big application with more specific endpoints or sub-services. So you can use the same approach as I presented in example in the demo with multiple alert rules, and then a specific part of those applications can be monitored. But it's also possible to use some specific endpoint and prepare some health check. And this health check endpoint can collect data from other endpoints and send everything to one rule in Kibana. So it depends what you want to achieve.
Thank you very much. And looks like we answered all the questions that appeared during the sessions. If you want to know something more, let us know by email and we can go further.
Okay, so that's all from me. I hope that presentation was interesting and inspired for you. And thank you very much for your attention. And I hand over the voice to Octavia now.
Thank you very much. Thank you, Shimon, for your presentation. Thank you, dear participants, for your attendance. The webinar will be available on our YouTube channel and on our website. I encourage you to watch our other webinars and to register for the upcoming ones. You can have a look in the chat window. I send you the registration link so you can have a look on others webinar that are scheduled for upcoming weeks. And if you have any more questions about Elastic Stack, about Enterprise Software House, or our other competencies, let us know, contact us. And that's all for today. After the session, there will be presented one more short survey. I encourage you to complete it. One more time, thank you very much, and see you next time.
Thank you. Goodbye.